Hello, myself Ajinkya Savarkar, and I am presenting my work Crosslink, a tool for comprehension and refactoring for polyglot or cross-language projects. So, Crosslink is a VS Code extension which is made for developers who are just joining a cross-language project which has more than one programming language. And they are experienced developers there, but they are novice for the cross-language database. So the motivation for developing this tool was to reduce the developers time, which is for single language it is up to 58%, but can go even higher for multi-language code bases. This is happening because of these challenges, like there is an increase in the cognitive load, and also there is an increase in context switching, which can increase their mental effort and can slow down their progress. Also, there is a difficulty navigating code and debugging cross-language links. So using our tool, we are trying to help developers uh, solve this problem, solve this challenge. So here is the tool. This tool I am for demonstrating. I'm using this GitHub repo OpenVDS master, and it has Java. It has Java and C++ files which are communicating with each other. So this is the interface of the tool, and I have opened one of the Java files which contains native methods which are communicating with C++ files. So here we are able to see there are two methods which are communicating with C++, and these are highlighted with green color. This is done by the tool, so it is giving developers a direct feedback. So green color is indicating that the declaration of this method is present in one of the C++ files, and if there is no method declaration present in any of the C++ file, then this green highlighted will be highlighted by red color. So this highlighting is giving developers directly feedback that this is the code snippet for where we are communicating with C++ file, and also it is telling that if the declaration is present or not present, or in other words, we can say the link is broken or not broken. Now to also help further we are giving developers a dependency graph which is showing all the dependencies on the file level. For example here is that uh, which Java file is connected to which C++ file is shown through this graph. So for example, here the orange nodes are the Java files and the blue nodes are the C++ files. So for in the corresponding example, we can see that there are so many Java files which are connected to this C++ file, and also we are able to see that there is a one Java file which is connected to two C++ files. Now in this portion we are seeing that there is a missing JNI node. Now this is indicating that there is at least one method whose declaration is not found in the corresponding C++ file. So also there is a search option which will keep the search files which we are searching highlighted, and dimming all the other files. So this way we can trace the required file. Now there is one more way. Now this graph is giving us information in file level. Now there is one more way which is showing the dependencies in on the method level. Now here we are seeing that for the corresponding Java file, there are there are methods which are communicating. It is listing them directly, and it is telling that that it hasn't found the corresponding C++ file. That is why it is highlighted in red color. If you scroll down, then we can see that there are so many methods present in this Java file, and all the methods are declared in this openvideos.c++ file. Now if you want to navigate to this file, we can click here, and it will directly navigate us to that point, navigate us to that file. Also, if you want to directly navigate to the corresponding declaration in the C++ file, there is an option directly above the highlighted code snippet to go that C++ file. So this will directly take us to that C++ file and open the corresponding declaration of that method. So here is the declaration of that method, and here is the implementation which is present inside that method.